Hi, Mrs McTaggart here, and in this video we are looking at a higher topic of differentiation, and today we're looking at velocity and acceleration. And please remember, velocity is just a really fancy word for speed. Those of you who do physics will know this, but if you've never done physics you'll be like, what? But velocity stands for speed. So just a reminder, I use this diagram a lot of all the different times differentiation comes up. Some of them are really obvious. The one we're looking at today is this one over here. Any mention of, you've already be aware of rate of change is a buzzword for differentiation, but acceleration, velocity also mean when to differentiate. And we're going to look at this little bit I've circled in more detail. So d of t stands for your actual initial equation. If you're asked for the speed or velocity in a question, that becomes v of t, which is actually just your differentiated line. Okay, so v of t, velocity in respect to time, would be your initial differential equation. But then if you want acceleration, then that's asking you to differentiate your velocity. Okay, so this gets a bit complicated, and we have this little thing here. It just means that I differentiate twice. But if I was doing my working for this, I would start with my little equation, and then I would get d of t, I would get v of t, which is differentiating that, and then I would get a of t, which is differentiating v dash t, which is d dash dash t, but you might not want to write it like that. Now, if you forget what comes next, like, oh God, does velocity means I differentiate twice, or is that acceleration? My little handy hint is remember the word diva, and it just helps you remember that it's your differential equation to get velocity first and then acceleration second. It might not help at all, but it does for me. So let's have a look. So here's my first question. The distance, so be aware actually some of my equations will not be f of x anymore. We're now talking about t in terms of time. So distance travelled by a model train over a bridge is given by this formula here, where t is the time in seconds after it starts. So we're asked first of all to calculate the velocity of the train after 6 seconds. Now velocity, remember my little hint of diva? So velocity means I've got to differentiate this equation here. So I'm just going to actually write it a wee bit nicer for you. So that, sorry my pen's gone wonky. That over 8 doesn't sit well with me here. So this is the same as 3t take away, and I'm going to bring that to the front as have it as an 8. That's a wee bit nicer. Okay, so we're asking for the velocity after 6 seconds. So what we have to do is we have to find v of t, which is differentiating this. So differentiating 3t goes to 3. 2 times that negative gives me a negative still. 2 times an eighth is 2/8. And remember, 2/8 is just the same as a quarter. So that would give me a quarter t. So this is now my formula for velocity. We want the velocity after 6 seconds. So we have to do v of 6. So we're just plugging in the number 6. So we've got a quarter times 6, which is 3 take away. Now, I not sometimes use fractions, but this is quite easy to turn into a decimal. A quarter of 6 is just 1.5. And then that would give me, 1.5. My units would be, now they haven't told me the distance, so there's maybe a wee misprint in my question. So distance from a model train would probably be metres. And we're talking about seconds, so let's go with metres per second. Okay, so that's that first one. And it's just recognising that word, if you see velocity, well, that means you differentiate. That's all it is. Let's look at example. Okay, let's look at example 2. So in this one we're told an object is thrown into the air. Its height is given by, and I'll probably just add that the height is given in metres for this one, which should have probably been in there. And we want its speed after 2 seconds. So speed would be s of t. Now that would be when we differentiate this. When we differentiate equation above, the 5 disappears. 30t becomes 30, and then we have negative 3 times 2 is 6, so negative 6t. So this is my formula now for speed. So my speed at 2 seconds is just 30 take away 6 times 2, which is 30 take away 12, which is 18. So my speed would be 18 metres per second at this point. Part B, when is it stationary? Well, it's stationary when your speed is 0, right? So if you're stationary, you're doing 0 speed. So I'm going to set my speed equal to 0 this time. So I'm going to have 0 equals 30 take away 6t. And bring over my 6t, I'll get 6t equals 30 and t equals 5 seconds. Basically what we've done there is I've found the roots of the object. So when it's thrown in the air, it comes up and it lands. And what's happening is it's landing at 5 seconds there. So the answer is 5 seconds. Okay, on the final example, we're talking about an aeroplane. An aeroplane is flying with its velocity given by this formula here, where t is the number of seconds and v is your speed in meters per second. So we already have the formula v for velocity, so I don't need to differentiate anything to get the velocity after 10 seconds. This is simply working out what I get when I sub in the number 10. So I have a third times 10 cubed, which is times 1,000, plus 2 times 10 squared, so that's plus 200. And then I have take away 50, and then I have add on 2/3. If I look at this, well, that's just really 1,000 over 3. I've actually got 1,002 over 3 if I add on the 2/3 at the end, plus 150. Now you could go to your calculator here. I don't have a calculator handy, so I'm going to turn it all into thirds. So I have, that would be 1,002 thirds plus 450 thirds, which is 1,452 over 3. And I've just done that calculation very quickly, and it works out to be 484 meters per second. Okay, part B, find its velocity after 2 seconds. That's just asking you to plug in the number 2. So v of 2 would be a third of 2 cubed, so that's 8 over 3. Plus 2 squared is 4, times 2 is 8. Take away 10 plus 2/3. Again, this would give me 10/3. Take away 2. Which is very like 10/3 take away 6/3 if I turned it all into fractions, which would give me 4/3. Or, sorry, I'm running out of room here, 1.33 meters per second as a decimal. And then part C, at what time is a plane at a constant velocity? So if you've got a constant velocity, that means that your acceleration is 0. So if I differentiate this, this will give me a of t. So 1/3 times 3 is just t squared, plus 4t, take away 5. Remember I said I can put that equal to 0, which gives me t minus 5, t plus 1. No, I've done that the wrong way around, haven't I? So it should be t plus 5 and t minus 1. And that gives you t is 1, or t is minus 5. You can't have minus 5 seconds. So the answer is 1 second after takeoff. And that is me talked all about acceleration and velocity. It comes up very rarely, I'll be honest, in exams, but you have to remember that velocity is to differentiate, acceleration is to differentiate twice. Thanks for watching, I hope this has helped.